Hi Anna, thanks for meeting with us today.
Hi.
Alright, so today we're going to do 4 different math tasks, and they're a little tricky, so it's okay if it takes you a while, okay?
Okay.
Alright, so the first task, is it okay if I start now? Are you ready?
Yep.
Alright, Tom has $403. He spends $96. How much does he have left? Estimate, please.
Can you repeat the question?
You can't use a calculator, sorry, I had to take your phone. Alright, Tom has $403, and he spends $96. How much does he have left? Estimate, please. It's okay if you don't get an exact answer, so 403 is the original, and he spends 96. What's your best estimate? You can't use paper and pen.
300
Okay, 300.
and 300.
Okay, perfect. That's a great answer. So how were you thinking about this problem to find this estimate?
I was thinking about subtraction.
Okay. Anything specific about subtraction?
Subtract the smaller number from the bigger number.
Yeah. That's perfect. All right, so now, without paper and pencil, how could you find the exact answer?
With mental math.
Ooh, mental math, that's a great term. So, do you think you can do that?
I could try.
Okay.
Wait, what were the numbers?
403, and then he spent 96.
$300 and 13?
Okay. Great. So how did you find that answer?
Well, you set up the equation in your head with the numbers lined up, and then if there's a 0, you take one out from the number next to it until all the numbers on the top are bigger than the ones on the bottom.
Okay, perfect. All right, so now you can use a paper and pencil to find the answer. So let me just get you all set up. Here you go. Got paper and a couple different utensils.
Thank you.
So now, show me how you would use paper and pencil to find the exact answer.
So, you would take 403 and then 94?
96.
96. Then, because the 6 is bigger than the 3, you would take one out of the 0, but because 0 is still bigger than 9, you would take one out of the 4, make it a 3, turn the 0 into a 10, but because that's not right, you would take out a 9 to make the 3 a 13 to make it bigger than 6. Then you would just solve.
There you go. That's great. So how do you know that your answer is right?
Because if you take 96 away from 403, you get 307.
All right. That sounds great. Do you think you could find the answer in another way?
You could. I don't think so.
Are you sure?
I believe I am correct.
Okay. Well, that's great. Thank you. All right, Anna, we're now going to start task R. All right, Bree, are you ready? Okay, cool. All right, so suppose a second grade student did not know what we meant by multiplying 4 times 6. How would you help him understand what 4 times 6 means?
Repeated addition. You could either add 6 4 times or add 4 6 times.
Oh, that's great. That's a great strategy. All right. Is there anything else you can do to help him, the second grader?
I don't think so.
Okay. That sounds great. That's a really great strategy. All right, so now, suppose that you know that 4 times 6 is 24. Could you use that to figure out 4 times 12?
Yes. You could either take 24 and add 6 to it again to find the answer, or you could just take 24, or you could just take 6 and add it 12 times, or add 4 6 times.
And you said take 6 and add it how many times?
6 more?
Okay. So, how could you use 4 times 6 equals 24 to figure out 40 times 6?
Well, you would know that 6 times 4 is 24, and it would take a while, but you could still just add the same amount to add it up, so you added 40.
Okay. Do you know how many you would have to do that?
You would have to add either either 38 or 30. No, 39.
Okay. Do you think there's any other math that you could use to figure out from 4 times 6 equals 24? Could you use 4 times 6 equals 24 to figure out anything else?
Well, I feel like with the 4 times 6 equals 24, you could use that to find what 6 times anything equals, or 4 times anything.
Ooh, that's a great idea. How would you do that?
Just by replacing the 6 with a different number and doing that added addition, or replacing the 4 with any number and doing the repeated addition.
That's really great. Thank you. I think those are some really great ideas. All right. Bree and Anna, are you guys both ready?
Yep.
Okay, cool. All right, so now we're going to move on to task S. So let's do some mental math. All right, count for me by tens starting at 40.
40, 50, 60, 70, 80, 90, 100.
Can you do any more?
110, 120.
Perfect! You did that wonderfully. All right, so now, can you count for me by tens starting at 52? It's a little trickier.
62, 72, 82, 92, 102.
Can you do a couple more?
122 and 132.
That's perfect. All right, so now, sorry. Okay, so now, read this number for me.
456.
Perfect. Okay. So what is 10 more than the number?
What was the number?
456. Okay, so 456. What's 10 more?
466.
Perfect. Okay, so now, what is 100 more than the number? So 100 more than 466.
566. 56.
No, you were right.
Oh,
66.
66.
Yeah. Perfect. All right, so now read this number for me.
5,678.
Perfect. What is 100 more than the number?
5,778.
Yes. Yes. All right, now, what is 200 less than 5,678?
5,478.
That's amazing. You did really good. All right, so now we're moving on to another one, so you don't have to worry about that one anymore. Imagine counting by tens. Which tens would 284 be?
What?
All right, I'll repeat it. All right, so imagine counting by tens. Which tens... Oh, wait, I'm sorry. Between which tens would 284 be?
28 and 29.
Great. All right, so now, between which tens would 3,261 be?
320
Mm-hmm.
or 329.
Okay, yeah, perfect. Those are great answers. Tell me another problem like the ones that we just did that you can do.
Tens between 100.
Mm-hmm.
10
Mm-hmm.
or 11.
Okay, yeah, that sounds great. Perfect. All right, guys, are you ready for the last task?
Yep.
All right. So task T number 1. Suppose you had a $10 bill and you wanted to exchange it for dimes. How many dimes could you get for the $10 bill? And explain to me your reasoning.
Well, a dime is 15 cents.
Mm-hmm.
So you could get for $10
Mm-hmm.
115 dimes.
Okay. How did you figure that out?
Well, because I just did.
I think that's great. Were you thinking about any numbers or anything in particular when you were thinking about it?
Well, I was thinking that $10 you could get more, you would get less quarters than you would dimes, but still more dimes than you would nickel.
Okay. Wait, so less quarters. So can you tell that to me again? That's a really cool strategy.
You would get less than you would quarters, but more than you would dimes.
Okay. And then did you say dimes or nickels? I forgot.
Nickel.
Okay. I think that's a good strategy. All right, so now we're going to move on to number 2. Suppose you have $4 and you want to share the money among 10 people. How much would each person get? And tell me about your thinking.
Well, you would have to divide 10 by 4 by 10. So probably like 25 cents each.
Okay. I think that sounds good. How were you thinking about that to get that?
Repeated subtraction.
Ooh.
But it would have ended up a decimal because 4 is still smaller than 10.
Okay. That's great. Do you think that you could solve the problem in a different way without using repeated subtraction? If you want, you can use one of these pieces of paper to think about your thinking. Or you can do mental math, whatever is easier for you.
Okay. Well, I don't think so, because division is subtraction, but subtraction is also a division in a way. Those are the only two ways of math that subtract.
Okay.
So you could split evenly.
Are there any ways you could show me on paper how you got your answer?
Yeah. You could do this.
Okay.
But because 4 doesn't go into 10, you would do 0, drop down the 10, put a decimal point because you can't change that number. Then add a 0 and drop the decimal point down.
Okay. Perfect. Can you tell me about your thinking with your math right there?
Well, this is long division.
Long division.
So it takes more than one step to get your final answer.
Okay. I'm just writing it down. I think that's great. Well, thank you so much for doing the interview with us today. I really appreciate you meeting us here.
Thank you.
All right.